We're asked here to write each linear equation in standard form. So to do so, of course, means you have to understand what standard form is. And standard form of a linear equation is when you have your x and y terms on the same side as the equation and then just a number. So really you just have a number equals number times x plus number times y, right? Where the x's and y's are on the same side. But the thing is that those numbers also have to be integers, and that's going to be really important in these examples right here. So for the first example right here, that's actually in slope-intercept form because it's in y equals mx plus b form. So to get in a standard form, you want to get x and y on the same side. So one thing you could do is you could add 2x, and then that would give you 2x plus y equals positive 1, and that actually would be a final answer in standard form since all of the coefficients 2, 1, and 1 are integers, and then x and y are also on the same side, and the numbers on the other side. For the next equation, you might want to get to your x and y on the same side first. So if you add 1/3 y, you'll end up getting x plus 1/3 y equals positive 4. But then there's an issue because not all of the coefficients are integers. So it's really just that 1/3 that's a problem. So what you'd probably want to do then is multiply by 3, because then 3 times x plus 1y, and then multiply by 3 on the other side equals 12. And that right there then gets it in standard form, where it fits all the criteria of standard form. For the next one, maybe get x and y on the same side, again, as per usual. So you'll have to subtract 5, 6x to give you negative 5, 6x plus 1/4 y on that side equals negative 7. And then, because you've got all these fractions, you're going to want to multiply both sides by something to kind of clear out the fractions. And so if you look at the denominators of your fraction of 6 and 4, you would be able to use the least common multiple of, say, like 12, because then 12 times negative 5 is negative 66x, and then 12 times 1/4 would be 12/4 y, but both of those fractions reduce down to integers because you get those integers right there. Just got to make sure you multiply the other side by the same number there of 12, so you end up getting that equation right there when it's in standard form. And then in the bottom row right here, if you get your x's and y's on the same side, so if you subtract, say, 0.8x from both sides, then you're going to end up getting negative 0.08x plus y equals, and that's just going to equal 0. And that's totally fine. It's just now you can't have any decimals, right? Because that's not an integer. So really what you can think here is if this goes out to the hundredths place, then if you just multiply this side by 100, then 100 times negative 0.08 actually just turns into negative 8x. But then you have to multiply the other term by 100, so you get 100y. And then if you multiply the other side by 100 to keep this balanced, 0 times 100 is 0. So that would be your equation there in standard form. And then finally for the very last one right there, it's actually already in standard form because you have your x, which has an integer coefficient, and you could treat your y's on the other side with an integer coefficient of 0, and then you have an integer on the other side. So it's just kind of in standard form already as it is. So yeah, we can just leave it, and there it is in standard form.